Now, in this discussion, we have a number of questions to provide answers to. So, the first one we have derive Taylor's series from first principles, and in our past lectures, we have earlier on derived this. So, we can just find the description. We can find the link of this lecture in the description of this video. Then the next one is that express sine x plus h as a series of power h up to the fourth term. Then use the expansion above to evaluate sine 44. Excuse me. So the next one is the failure of a machine in service is computer monitored by the growth signal curve display. When the signal curve grows to its critical point, the machine trips off itself. If the signal function is represented by this, verify the applicability of Hospitali's rule on f of theta, hence determine the value at which the machine trips off. So we are going to look at that later on. But to begin with, let's look at part 2 of A to express sine x plus h as a series of power h up to the fourth term. So to begin with, let's first look at, we are going to first look at f of x plus h according to the Taylor series. Taylor's series. So what we are going to do, f of x plus h, we are going to expand it, and this is the same as f of x plus h f prime f of x plus h squared out of 2 factorial, the second derivative of f of x plus h3 out of 3 factorial, the third derivative of f of x plus we still can put h power 4 divided by 4 factorial, then the fourth derivative of f of x, and so on and so forth. Maybe we can say up to hn out of n factorial, the nth derivative of x. So what does that mean? If you have sine of x plus h, this is going to be sine of x plus, obviously, h times the first derivative of a sine, which is going to be a cos x, plus h squared divided by 2 factorial, now times the second derivative of f of x, which becomes negative sine x. Then plus, okay, h cubed out of 3 factorial times the third derivative of f of x, which still becomes negative cos x. Then plus h power 4 out of 4 factorial times now the fourth derivative here. The fourth derivative becomes now a sine of x plus dash dash plus many terms. So that's what it is meaning. Now, what if we have a sine of x minus h? What is this going to be? This is also going to be sine x, now minus h cos x. Wherever there is h, put there negative h now. So plus, if you have negative h squared, it remains h squared divided by 2 factorial, then into negative sine x. Plus, if you have negative h, when you cube it, you have negative h cubed out of 3 factorial into negative cos x. Then plus, okay, this is h to power 4, so when you have negative h to power 4, it remains h to power 4 divided by 4 factorial sine of x. Now what I can do, I can rewrite sine of x plus h, and this is going to be sine of x plus h. Okay, let me just copy what is up there. We said that is h cos x, then h cos x, then minus, this is going to be minus h squared out of 2 factorial sine x. Then we also have plus h cubed out of 3 factorial. This was cos x. Okay. Then plus h to the power 4 out of 4 factorial sine x. So since they wanted only up to the fourth term, then we are going to take away this. We are going to strike it off so that for 4 terms we have sine of x plus h equal to sine x plus h cos x minus h squared out of 2 sine x, then plus h cubed out of 6 cos x. So what is sine of x minus h? Just put in the negative h in here, so this becomes sine x plus or minus, is minus. So minus h cos x, obviously minus h squared out of 2 sine x, then minus h cubed out of 6, okay, cos x. So why am I looking for this? Because I know I'm told to evaluate sine 44. So now to evaluate sine 44, this is the same as sine 45 minus 1. Remember, all of these are in degrees. Now, what are we going to do? That means our x is equal to 45 degrees and h is equal to negative 1 degrees. But I must convert each of these ones into radians. So x will equal to 45 pi out of 180. So what is this? By 45, 1 by 45, 4. So this becomes pi out of 4 radians. And what is h? H is equal to negative what? 1 degree is equal to pi out of 180 radians. And what does this mean? Our x, pi out of 4, x is equal to 0.785 398. Then h is equal to pi divided by 180, but when it is negative, so negative 0.01745. Maybe if I take 5 decimal places, okay, let me take 6. So I add a 3 here. So what does that mean? Sine 44 will be the same as sine 45 minus 1. And this is going to be substituted in equation. We are going to use equation star star. So sine 44 will equal to sine x. Sine x, we are going to take sine of pi out of 4. So sine of pi out of 4 is the same as sine 45, which is the same as 0.7071. Yes. Then we subtract. We are going to subtract. Let me work that on our calculator. We must remember that cos of pi out of 4 is the same as sine pi out of 4, and this is the same as root 2 out of 2. This is the same as 0.7071. So that should keep in our minds. So wherever you see sine 45, it is the same as cos 45. So when I evaluate this, I find that I needed to change this into a negative, because when I differentiate my sine x here, which is carrying a negative, it will go with its negative the other side. Because I had sine x, I got cos x, cos x I got negative sine x. So negative sine x differentiated with respect to x, I also get a negative cosine x. So if I introduce in now x minus h, that means h becomes negative. So I substitute wherever there is h, I put negative h. So this becomes minus h cos x minus h squared, okay? So which remains h squared out of 2 sine x. Then here this becomes minus, then minus h cubed, whereby h cubed, which is negative, becomes a negative, and the negative cancels with this, becomes a positive. So out of 6 cosine x. So now when I come back here, when I'm substituting, I will have 0.7071, which will be the sine of x, that is sine of pi out of 4, then minus h, which h we calculated as negative pi out of 180 radians, and we are having 0.01745. So if I multiply it by cos x we said it is the same as sine 45, so which is the same as pi out of, root 2 out of 2, which is 0.701. Then minus that h squared divided by 2 sine x would give me that value. Then plus the last one, h cubed out of 6 cos x, gives me this. So when I evaluate this, sine 44 is approximating to 0.69465. When I evaluate my sine 44 on a calculator, sine 44 on a calculator gives me sine 44 degrees is equal to 0.69465, that is from the calculator. So you can see the Maclaurin's theorem, okay, which is actually this is Taylor's series. Taylor's series is giving us the decomposition of sine 44, which is giving us a value that is close to the close to the exact value that we get when we evaluate it using our calculator. So that's all that we needed. We are first told to express the sine of x plus h as a series of power h up to the fourth term. And that's what we did up to here. Then it is from there that we had to manipulate that sine of x plus h into sine x minus h, okay, so that we get something that is related to sine 44 because sine 44 is the same as sine 45 minus 1. Then we had to first of all convert the 44 degrees, the 45 degrees into radians and the 1 degree into radians. And evaluating that, we would get our answer as that.